Good. Then we're done for our talk for tonight, and I'm very pleased to announce that we have again a community member stepping forward and sharing his experiences. Salah has been working as a senior software engineer for decades at this point. He's currently at Österreichische Post AG. So if you're missing one of your parcels, ask him, he might know. You're not? Okay. I tried. Sorry, guys. Please, big round of applause to the speaker from tonight.
Okay, hello. Thanks for having me. I'm Salah. Today I'm going to talk about the real-world use of chain of responsibility design pattern. I've prepared a demo project, so we are talking about any advantage and disadvantage of this design pattern comparing to traditional way of using that. So what is chain of responsibility design pattern? Basically, it's a behavioral design pattern where a request is passed through a chain of objects. And each object gets a chance to handle it until one of them actually does. So this is just a brief explanation of the chain of responsibility. We go through it. Who am I? I'm Salah Akbari, so senior software engineer and backend architect in Post. I've worked since 2002. When Stack Overflow was still active, I was also active and got a lot of reputation there. Before that, we have such an excellent and interactive way of getting the answers with AI tools. You can take a look at my profile if still is there. This reminds me of this picture. Stack Overflow walked so ChatGPT could run. And basically, I don't have any idea if still it's a good replacement for Stack Overflow, whether we have, since we don't have a public knowledge on the web, what happens in the future. Maybe it's a good topic that we can discuss afterwards during the drinks. So yeah, let's see. Let's get it started. So I've prepared the custom exceptions for this demo. Why we need the custom exceptions at all? I've prepared some notes here because we have a centralized error handling. We can handle all exceptions in one place. We have consistent error responses across all endpoints, centralized logging, and many advances if we have a custom exceptions. What does this mean? So let me start with the API. In this API, I reproduce all of the exceptions like it's not switch to Visual Studio.
Need to stop the presentation, probably.
Mm-hmm. Yeah, because it's on slideshow, yeah. Okay. Okay, good. So I've prepared a range of numbers like negative 1 until 9. So each one will reproduce one exception type. For example, if I push here, a bad request will be thrown here in the code, and I will see the final result, which has been returned to the end customer like this. So this is just how it works, and I will explain in details later. So, for example, number 4 is for a conflict exception. Okay, let's see how I've handled the full flow of this. I've created a class. It is called exception middleware. In this exception middleware, which I've registered in the program CS already in the middleware, Uh, I've created a dictionary so that it maps each kind of exception to a method, like not found should call the handle not found exception, bad request should call the handle bad request exception, and so on and so on. So how the process works in the middleware, if I set a breakpoint here,
Increase the font size a little bit, just a little bit, the font size.
okay.
Control plus.
Yeah, so I guess maybe this one looks better? Okay. So this is the first point, that once I execute this one, it comes here. It works like invoke method is the ASP.NET core middleware pipeline. We have a set of middlewares have been already registered in the program CS. The first point comes here, and it calls the this exception handler middleware. Once it goes, it will continue until it comes to the endpoint. One exception is thrown here. And once I click the continue, it comes to the catch part and will find the dedicated method for this reason, which is in this case the bad request. And once I click the continue, it comes to the final result. So for example, here for the handling the exception in the mapping, if I throw the bad request, in the bad request, if I go to the implementation, you see here we have the handle bad request exception. And for example, for the conflict, which I just thrown it, like here, so this is for conflict. Again, at first, the invoke method will be called. It goes to the endpoint. One exception is thrown. It will go to the cache. And finally, in the catch block, it maps to the handle conflict exception. And we have a custom implementation, for example, for this conflict. That could be anything. That could be just some external services, some bad requests, and so on and so on. So as you see, most of you, I'm pretty sure, that already found a lot of problems with this implementation, which I fully explained with the details, but this is just a traditional way. Instead of dictionary, some of the projects I have seen some if and else statements, or maybe just switch case, and so on. So this is how exactly this works. In case in the future, I need to add another exception. I come to here, I will add another element to this dictionary, I will implement another method, and the rest. So let's back to the slide. What's the problems with this implementation? This implementation actually violates the single responsibility principle, violates open-closed principle, and it is hard to test individual handlers. What does it mean? Why it violates the single responsibility principle? The design is tight coupling, and we have a lot of design issues. Middleware has too many dependencies. If you want to define the responsibility of this class, what would be? I mean, there are a lot of responsibility that this class at the moment handles. So there's a high complexity and long method count also here. So for example, if you want to find something between in this class, you have to scroll a lot until you find the proper section, so that go there and just fix it. And the rest that you see here, if all handlers are in one file, it quickly becomes long and hard to navigate. So testing challenge. Testing challenge also is another problem with this approach, because all of the tests must go through the invoke method, which is the only public endpoint, only public method in this class, because the rest of the methods are private. And when we have something in private, we cannot test inside. So maybe the question is that why we are not changing from the private method to public, because it simply breaks encapsulation, and this is not the thing that we want. Also, it would be like a confused API. If we have everything in public, So which method actually should I call? And the rest that I will show you, like the setting up the test would be definitely complex. And it violates also the interface segregation principle. So given that we have it like an interface, and if you want to implement in some client, we have to implement all of them. So let's explain all of these topics that I mentioned. The single responsibility is pretty clear here. We have a lot of responsibility for this class. So if I want to show you the testing of this middleware, I've created a test class here for example, for exception handle middleware test. So if I want to test a specific test case, like the bad request, since I don't have any dedicated class for bad request handler, I have to write all of the tests in this middleware, in this exception handler middleware class. So for example, this is a test case which should return 400 when bad request exception thrown. So what problems I have with this approach? I cannot test handle bad request exception directly because it is private. So I explained. So I have to go through it with the invoke method. There are some alternatives for this which are not recommended, like having it with reflection and so on that I don't want to discuss about those practices which are clearly bad practices. So for example, here, if I want to have this exception handle middleware for this bad request, I have to add the service unavailable exceptions. Why I should pass the service unavailable exception handler to this exception which is only for bad request? But I have to, otherwise I have to pass the null, which is something else, which is not also a good practice because it violates the interface structure. So you see, since I have declared these two services in the exception handle middleware, I have to pass them for any kind of exception here because of unrelated dependencies that has been declared in this class. So yeah, this is all issues related to exception middleware. Another known problem here beside the test that we discussed is that the issue with open-close principle. What is open-close principle? Open-close principle actually means that a class should be open for extension but closed for modification. But in order to add another exception type for this class, I have to open the file, I have to modify the existing code, I have to add code to existing class, cannot extend without modification because there's not any other way for handling a new kind of exception. Risk breaking 8 existing handlers. For example, I'm going to add a timeout exception, but what if by mistake I modify some other methods during my change? And testing the software would be also slower because the QA must test all of the functionality together, even if I add some new functionality, because all are together. So higher risk of production bugs and merge conflict. This is a good example of the impact, the real world impact of not following OCP. So for example, on Monday, a developer will create a new exception type of this class. Another day, another developer will add another one, and both are creating the pull request. Since both are pointing to the same file, what happens? Merge conflict, simply. So this is the things that motivate us to think about some other way to refactor this. And what's my suggestion here? One candidate could be the chain of responsibility pattern. As I said, each handler class processes one specific request. If it is related to that request, it will handle it. Otherwise, it passes to another element of the chain, which could be, for example, it could be started from the not found, and then if this is the not found exception, it's good, I will handle it. Otherwise, I pass to the next element, which is a bad request, and so on and so on. So handlers actually are linked in the chain. This should follow the single responsibility and open-close principle, as I will show you in the next implementation. So let's go back to Visual Studio. Here I've registered two middlewares. One of them are related for traditional handling, and one of them is for the chain of responsibility. So I simply will comment out this one and go back to use the chain of responsibility exception middleware. First of all, I will test all I've done, and then I will explain, starting by the exec flow, how it works actually. So okay, again with the same flow. For example, I have 5 execute. It comes again for this time for the chain of responsibility exception middleware. This invoke async is the ASP.NET Core HTTP, and this is the same one. And I believe maybe Microsoft also has implemented the chain of responsibility for this invoke async method. So first, it would come to the invoke method. Here, I will switch to the endpoint. Some exception is thrown. It goes back to the catch. And in the catch block, we point to the next element in the chain, which in this case, it would be bad request. I don't remember which ID I passed actually. And it will be executed like this, and so on and so on. So this is just the same functionality, the same result I've gotten because I've copied the same functionality that I showed you earlier. But let's take a closer look before explaining that, because maybe it is more clear. So I have the chain like this. In program CS, I've declared the chain like this. I have the not found exception. I've set all of the elements in the chain. Not found is the first one, then it is bad request, validation, and until the external booking service exception. And at the end, we have the unknown. What does unknown means here? Any exception beside these exceptions. So for example, I have some overflow exception or timeout exception, which I have not handled at the moment. And at the end, it will go to the unknown exception, and maybe I have written some specific logic for that case. So what does this mean? This means that if I show you here, I have a dedicated class for each exception. So if I start with not found exception, you see I have a breakpoint here just for one of them. For example, I'm trying to reproduce the conflict exception. So at the first it comes to not found, then it goes to bad request like this. And let's set a breakpoint in the conflict exception handler. So another time I will execute. Let me make sure about that. Product. Hopefully the font is fine, right? Okay, it's good. So conflict is 4. When I execute this, as I say, it first come here. It goes to the product query. I follow the CQRS pattern with mediate R here. It comes to this one. We'll throw some exception, goes to the catch, and in the catch, first goes to the first element in the chain, which is not found. So what happens here? Our exception here is conflict, is not found. When I click next, it comes to the next if statement. For the next if statement, the second element in the chain is bad request, and again, this will not be executed because it is not bad request. And it continues until it's found the proper exception that has been thrown, which in this case, it is conflict exception. So you see here, the conflict exception will be handled here. We have the logging functionality, and as you see, the log works here. We have logged somewhere, and once I click the continue, I'm getting the same result as I have. So basically, you can simply compare these two middlewares. In the chain of responsibility, this is all that I have. So, but comparing to the exception middleware with a large file which handling everything, so this already will answer and cover all of our concerns, like single responsibility. What is the responsibility of this middleware? This is just to handle and finding the proper exception, that's all. And for each exception, I have a proper type. So for example, bad request handler, conflict exception handler, only focus about that specific exception. So testing would be pretty straightforward in this case. So if I can show you from the testing point of view, I've created some tests, application test for example, I've created a class specifically for bad request. I don't have to create a general class like exception handling middleware. I've created a bad request exception handler test, and all of the tests in this class only points to the bad request, nothing else. So for example, here, since I only deal with the bad request, I don't have to reference some services which I don't need, like the previous example with service, with external services and any other part. Only logger here is needed, and that's all. So the first advantage here is that we are testing only bad request, as I said, nothing else. So simply it claims it, and we can simply verify the response body. The second advantage, as you see here, is that, for example, in the not found exception, so we can also, not only we test the bad request functionality, we can also test whether what is not related to bad request, what is not my responsibility. So, for example, this can test the not my responsibility path. So here, deliberately, I have created a not found exception, and we have asserted that this should not be handled by bad request exception. So this is the second clean way of handling the test related to the chain of responsibility way. And again, also we can test the behavior with mocks, very easy. And the most interesting part is that we can easily verify logging behavior. If you remember, we couldn't do this before, because the logging and the logic was buried with private methods. So we didn't have access to that to verify what happens actually inside those private methods. But here, as you see, and I have shown here, you can see that we can easily assert what happens in that specific case. So here, this saves us a lot in terms of duplication, in terms of following the single responsibility and open close. What about open close here? The next day I'm supposed to add another exception type. All that I need to do is just creating another class, and that's all. So for sure, not any kind of conflict happens, because if my colleague also create another exception, that would be another case. And all that I need here is just going to program CS and just adding that to this chain, and that's all. So this is the way that chain of responsibility handle what I want. Going back to PowerPoint. Some explanation of what we have done just now. So exception is thrown, starts the chain, each handler check if I can process the exception. If yes, handles and return response. If not, passes to next handler. And unknown exception handled by last handler. The next topic, I believe, let's first focus about the key advantage, as I explained already. And you see, this is easier to extend. New chain, just create a new handler class and link it to the chain. No need to touch the main handler logic. Better separation of concern. We have the open, we are in line with the open close principle for sure. As I proved, and readability and maintainability. Also, testing would be far easier, and each handler has a single responsibility in this new approach. So, testing also, like what I said, we have just seen that we have the test that we can test not my responsibility pass, the exact responsibility of that handler. We can test the chain with mocks. We can easily verify logging behavior and any other behavior which only could be found in the private method, in this case, which are the only public way to handling that. The next interesting topic is performance. Maybe you have a question regarding that. So we have a chain. What happened for that? What if, because I mean, it sounds like it is slower because it goes to the not found, then batch requests, then conflict, and so on and so on and so on. I would say since, please help me, but I don't think that we have more than 10 or 12 exception cases in any organization or any company or private project. I mean, based on my experience, at maximum we have 15 cases. And for 15 cases, that would be totally fine, and it is fast enough. Unless for the larger one, this still needs to be measured. I've created a benchmark. I will show you what happens actually before going to this proof. Let me switch back to the Visual Studio. Okay. If I haven't missed anything in the explanation, I will go back, or maybe in the QA we can back and just explain. But for now, let me show you what I've done for the benchmark. So for the benchmark, let me go to the benchmark project. Just a command. So I will execute this benchmark in release. Probably you agree with me that in release we should compare the results because definitely in debug is slower, and what's important for us is just what happened exactly in the real time. And once the application is deployed, what's the expected behavior of that. So let's see. This is the benchmark I've created with the new .NET 10. It will go for all of the exceptions the traditional way, and also in the chain of responsibility way. We'll compare everything, like the speed, like the memory allocation, like the standard deviation, the error case, and so on, everything. So here for me, I think I had 10 cases. So okay, let's take a look here. You see all of the results here are under like 120, between 120 and 140, 100, something like that, microseconds. So it's not something really huge here. Also, you see maybe for the next run, for example, the one that I've run and I will show you in that slide, are different but more or less similar. And in terms of memory allocation here, also we have something like 20, 19 bytes. So all good. You see also the rank for most of them are 2. And for example, the last in chain, which is the unhandled, because it is expected. It goes from the start until the end. So it is expected that to be a little slower because it's the last one, but also it's not a big difference between that. So, and this is just a run. Maybe the second run and the third one are different. For example, there are some cases with the traditional second to last also takes longer than some chain of responsibility, and in terms of memory are more or less similar. And what I have it, for example, here, what I've done it in home was something like this, which interestingly, the chain of responsibility was even faster in terms of speed and also memory allocation. So this is just some results that need to be measured several times. But what's important here, this is also, you see, there's a case here in terms of memory and also in terms of speed, mean, median, and rank. All you see here, the chain of responsibility looks better or in worst case similar. So here you see the nearly identical, and the differences here I believe that is really negligible. So not something to consider and to be worried about, and less likely we have more than 10 or 15 cases in my opinion. So since in terms of performance we are good, I guess that we can adopt for chain of responsibility pattern. We can decide to using that because of many benefits that we explained already, like the architectural benefits of chain of responsibility, testability, clean code, and being in line with all of the solid principles like the single responsibility and so on. Another tool here that I've noticed, it's a little too much for just this simple decision, but that was the Sharp Lab. Usually, I mean, for these cases, it's pretty clear for me that, yeah, definitely I would vote for the chain of responsibility because of the many benefits, because I've already measured the performance and I've seen everything. But if I'm asked to from the organization or from the several point of view, I would go and see what exactly happens in the Sharp Lab or in the lowest version of the C#. What is Sharp Lab? Actually, Sharp Lab is a .NET Code playground that shows what exactly happens for a C# when it compiles, what it will be converted to. So you can just take a closer look, find more information by this blog by Andreas Blanc. Also, I have an example here. For example, this was more useful for me. This was again a Stack Overflow question a few years ago, 9 years ago, someone asked, why, for example, int plus string becomes string? And I couldn't answer this question until I went to the Sharp Lab and found what exactly happens here. And that was my answer, that I went here and found out what exactly happens. And this is a use cases for when exactly we should use some tools like Sharp Lab. Actually, at that time, I used another tool like ILD, sorry. This is when it's in the slideshow. I should come. Okay, yeah, that was the thread in the Stack Overflow, how int plus string becomes string. And the result, for example, for this one, that was an interesting question, was like going, and I found that method. And we'll show you how to use the Sharp Lab in case you are not familiar with that. And that was the result actually I've gotten with Sharp Lab. You see here the IL code that could be also a lowest version of the C# also, depending on what you need. And here I found out the result. The tool here was called IL the assembly, but that would be the Sharp Lab also. And I believe in the Roslyn that should be something similar. So here, how I've used it in my .NET project. So going back to browser and, for example, sharplab.io. So I will create 2 tabs here, and I will compare one by one. I've created the minimal version of both middleware because you need to provide something which is actually compiled in Sharp Lab. Otherwise, you have to create anything. So let me find it in the Sharp Lab traditional. So here I have this class. As soon as I paste it in the left pane, it will be converted to the lowest version of the C#, what actually the compile. Here you can see also other cases like seeing the IL, but I think this is, to be honest, is too much for this, but you can see only the C#. So from this minimal version, I'm seeing some cases. You can, if you don't understand what it generates, you can also use AI. You can just paste what you have gotten here, just paste it to some AI tool and just please analyze this for me. What's the advantage and disadvantage of this code? And it can definitely explain it for you. What I have it here, if I show you, I think it's easier in the PowerPoint, and I will go back again to this one. So in the Sharp Lab. I'm not sure if it's clear enough or not. So I've seen in the traditional way 2 new hidden objects created in the heap. And unlike the chain of responsibility, with 0 new hidden objects were created here. So I will show you later in the code itself. I think it's a little small here, but so for example, there are some steps in the old way. We have the expensive dispatch path. What is the dispatch? Dispatch simply means how does the code decide which method to call to runtime. And here we have more ways until we find the exact flow. So step 1, create a closure object, link scan for entire dictionary, because it needs to find the exact matching in the dictionary. And then it creates another object here with this new func in the heap, which is slow, definitely. Or you can just imagine something in heap or something in stack. And we'll go for the null check and invoke via delegate and so on and so on. But here in the chain of responsibility way, we have only the direct virtual dispatch. Step 1 simple is type check, which is just a single IL instruction. In the Sharp Lab, if you select the IL, you can just compare it, you can verify that it is only one step. And step 2, just direct virtual call to next in chain. So this is what I have observed in the Sharp Lab. You can also take a closer look yourself and find out what I mean here. For example, regarding the objects which are created in the new link, it's somewhere here. It's a little too much, but maybe you can just search for the new keyword and find out what happens. There are some other cases for the Sharp Lab to consider, like the state machine and so on and so on. You can also search, get some information about those. And I guess this is a good point for decide whether this new approach is good for me or not. Depends on this. So we are verifying this from the performance point of view, from the compiler point of view, from the code that is exactly generated by compiler, and from the best practices, and of course complexity. Maybe you have a small project and it doesn't worth to spend such a time to just find out a good pattern for that. So this is like a trade-off. This depends on what you need and what's the exact situation that you have. So this is for the Sharp Lab also, that I just quickly considered that. The last point here is just adding a new exception type, which should not be a case. I'm just going to show it. Maybe it also shed some light on some cases that you are not aware, or maybe we are missing that. So as I said, we have a API. From this API, very simple API without any kind of consideration, because my main focus was about implementing that query. So as I said, this is, I've handled everything in the product query, which is a mediate pattern. So I've created another case. For example, if ID equals to 10, I have another kind of external service exception. For example, this is day number 2, and the requirement is like that we have been introduced for our company a new services, and we have to handle that one. And it is called external service exception. What's the steps that I'm supposed to do? Here I go to the exception folder in the application. Come on. And you see I have some exceptions here. I will add another one. Application, come on. So it is external service exception. Service exception handler, external service exception. Yeah. So the first step, for example, is just adding our custom exception here, which in this case it is external service exception. That could be anything. So this is just a very basic one. Once I've added these exceptions here, The next step is going to program CS. I'm commenting out again the chain of responsibility way and using that classic way of handling that. Just I want to show only how much effort I need for each case. So, for example, this is a kind of also a summary of what we have done. Here, once I've registered this middleware, I'm going up. I will add all of the necessary configuration here. So the exception handler here also should be added to the middleware. Yeah, here. The models, exception handler, exceptions, handler, external service exception handlers. I've added them to my program CS registration. Will add everything that I need. Sorry, this is related to chain of responsibility. No need for this one. And that's it. No, I've created a custom type for my exception, which is related to new exception type. The next step is that coming to this big class, and I just simply add another type here, which I've already added, just for showing. And you see here what I do, just uncommenting this one, which is for handling external services. And I have some method here, which I've already commented again, like this one. And it should work just after adding that to the constructor and register that, it should work smoothly like this one. What happens for the chain of responsibility? For the chain of responsibility, I have still that exception type that I've created here, but all that I need to do is just going to program CS and just adding another step here. That's pretty much of what I mean. So I guess that's it. If I haven't missed anything, I guess I covered all of the cases, so I'm open to any possible question or, yeah.
So as you yourself know, I'm a PHP developer, but these concepts were, I think, common in various programming languages. My question is, how do we detect how would we detect violations in the open-close principle? How do we know if they've been violated? This pattern, this design pattern is one of the ways that we could check if this design pattern is implemented or not, but obviously it's not just this. There are many ways to do it, as you said. And aside from asking the AI, you go and find whether there are violations of the principles. How else would a reviewer or somebody who looks at the code find out whether whether this principle, the open-close principle, is violated?
Yeah, that's a good question, and I believe it is not related to the language. It could be because the solid could be handled in any language. So, for example, the first question in this case would be that you ask yourself whether I'm going to modify this class in the future or not. And that's a quick answer for you. In case there are some possibilities for this class to be changed too much in the future, that's the first signal that let you know that you need to consider about that. So for example, I can just simply show you. This product query definitely violates the open-close principle. As you saw, I had to add another cases for ID 10, and I've modified this class. So this class clearly will violate that open-close principle. And in this case, for example, one big signal is like that you have a big kind of switch case statements or if and else if statements with some specific classes. That would be a good signal for you that remind you that please be careful. If you continue on this way, probably you will violates the open-close principle. And what's the workaround for this one? For example, if in the real world, I just wanted to do that, but I just keep it like just simple. But for example, you can follow the strategy pattern for this case. How? I mean, the simple strategy pattern here, I've created only for one case and just left it out. For example, you create a service unavailable validator here. And with the service unavailable, each validation role has its own class. So it is something like the exception handlers, like not found and bad request and so on. And this is something that will guarantee the future you won't violate something. Another topic which is similar to this case, again, I'm referring to another point for the open close. Let me find it. Where was the open close topic? Here. So here it's a very good example for me. I've learned from this one. Again, another post here. Why the link methods are extension methods, and why? What's the reason for this one? So the answer for this question, as it's been explained here, the first version of the .NET, not the first version, actually, from the IEnumerable was introduced, I guess, in .NET 2, as mentioned here. And at that time, we didn't have link. Link introduced in .NET 3.5. And what was the solution for Microsoft? Microsoft should have changed the implementation of the IEnumerable to include those classes. No, because that violates the open-close principle. And the solution for Microsoft was to adding all of those methods via extension methods. And that could be a solution for what you have asked, and the signal would be just how much you are likely to change that class. So this is like covering the open-close principle. Any other question? If not, that's pretty much it.
One question.
Yeah.
So, of course, it's a demo, so you want to keep it simple, I suppose.
Yeah.
Assuming you have production code and you want to reduce coupling even further, do you think, what's your opinion about letting those exception handlers register themselves?
Mm-hmm.
Is this an option for you, or do you also think, well, depends on a case-by-case basis, because it's work to actually do this you know,
okay.
To register them?
You mean even more refactoring of what I've implemented?
Yeah, so that you say, get me all exceptions in this folder and register them automatically,
mm-hmm.
and chain them automatically, and then add the unhandled one at the end.
Mm-hmm.
So that you don't actually have to edit the location where you add a new handler or you add a new exception type. Do you do that in
Definitely. I mean, as far as it's possible for me to refactor and just to improve the code. I mean, but before that, I will first take a look if I get any gain from the performance point of view, from the refactoring point of view, from the reusability point of view. If so, I would definitely do that. Why not? I mean, less code would definitely always works. So, I mean, for example, also here, I have a lot of duplicate codes in the handlers. You see, for example, here, for this one, or maybe for the bad request, this is the same functionality. I can also even refactor that. I can also refactor the program CS, because also in the program CS, I have to handle all of these services to get those and just adding them. So definitely I can just maybe even create another middleware or another module for those to make them automatic. But it doesn't force it for just a simple demo project, as you said. Yeah, definitely. Yeah. Any other question? Otherwise, stage is yours. That's all.
All right, if there are no more questions, thank you very much. Please, big round of applause for the speaker tonight. As usual, we got our speakers